Today in MATLAB Practical Examples, we are going to generate a random shape, fill that random shape with n random points, and then read off the coordinates of those n points. So if I run this code again, we'll see that instead of getting this random shape, we could get this one, or this one, and so on. The general procedure here was to just generate the random vertices for the polygon, and then to randomly generate points and test whether they were in or out of the polygon, throwing out those that were out of the polygon. Finally, we take that stored list of points and show them in the command window as one matrix. Let's show how I solved this problem from beginning to end. This is the email that I got from a MATLAB user that started me with this problem. Let's look at it how I did. The first thing I said was, well, we have to generate a random shape. That will be no problem. I can just use the rand function. I need to fill the shape with n points. This will be more difficult because I need to know whether a point is in or out of the polygon. The final part is reading the coordinates of the endpoints in the matrix. That will be very easy. So the difficult part was knowing whether the points were in or out of the random shape. To me, this sounded like a computational geometry problem, so I went to the documentation, and once I got to documentation, I just did a search for polygon. See if anything good came up. Now, whenever I get the documentation search like this, I like to sort it by product. It gives me an idea of what I'm looking at by looking at the product. I probably don't want anything from the mapping toolbox. I probably just want core MATLAB. So I'm going to scroll down here and see if anything strikes me as interesting. Looking in here, introducing the patch objects, that's going to be graphics. Poly area would tell me the area of a polygon, but this one, in polygon, that sounds very useful. So I click there, and I can read the documentation, but I'm just going to look at the example right here because that seems the most practical. And I see that there is a nice little example down at the bottom. I've got that code. I'm going to go back to MATLAB, and I'm just going to paste it right in here where my problem statement is and hit run. Okay, that looks pretty good. I think I'm just going to modify this to get rid of the points that are outside and to allow a more random choice of the values for the edge, and that should be good. So let me dock this figure so that we can watch it as we run here. I like to move that out. And the first thing is I see that we are defining xv as the vertices of the edge. And I notice that they are more regular the way they're done here. I want them to be random. And something else that I see is that I repeat the first indice at the end of the list of polygon faces. That must be important for in polygon. So what I'm going to do here is replace this where we generate xv as a regular polygon and just say xv equals rand. And I don't know how many points I'm going to want, so I'm going to say 1 comma num vertices, or num edges, because we are going to repeat. I like to have camel casing so it's easier to read. And then I like to show how these things are parallel with one another. So I'm going to copy, paste here. And so when I look at these, it's quite obvious that xv and yv are very much the same. Now I'm using this num edges. I should probably define it right up above. And I'm going to say I want 10 edges for now. We can change that later very easily. As I said, I like to keep that parallelism, so I'm going to space that out like this. And we've just made a little change here. I like to do incremental testing, so I'm going to hit F5 to save and run. And it doesn't like what I did. What's going on here? I don't know. Let me put my breakpoint in here and hit F5 to save and run. And immediately before that error, now I can see, what does this mean? Cat arguments dimensions are not consistent. Well, let's look at xv. Okay, it is a row vector, and then I'm trying to concatenate with a semicolon, which is going to say drop down to the next line. And then I put in just xv1. Well, of course, that's no good because I'm trying to add a second row that's only one value wide, and MATLAB doesn't like that. Let me just transpose these right here, and we should be good. In fact, instead of transpose, what I'm going to do is just say, let's make the original num edges by 1, so it starts out life as a column vector. Okay, I'm going to save this. That's going to get me out of debugging mode. And let me hit F5 to save and run again. Now it worked just fine. If we look here, it's not as regular of a polygon, so I'm going to want to zoom in to look at this to see if it got it right. And there we are. So this does indeed look like it's working. The next thing is I need to have a certain number of points that are inside of the polygon. So I'm going to say num points in is equal to, and let's say 20. This is just an arbitrary number. What do I want to do? Well, for I equals 1 to the num points in, and I'm going to say we're going to loop through here until we find a point that's in. So I need a flag. Flag is in equals 0 because my first assumption is the point is not going to be in. And then we're going to do a while loop. While not flag is in, I'm going to say I need to generate a random point. I don't need it to be normally distributed. I'm just going to use a random number. That means it's going to be from 0 to 1. And just to remind myself, I'm only making one point here. Again, with the parallelism, by putting the two lines that are similar to one another on top of each other like that. There we go. I'm going to generate my points like this. And now, instead of being in, it's going to be flag is in. I like to use flag for any binary variables that I create. I think it's easier for when I read this to know flag is just going to be a binary, and the description should be self-explanatory. Flag is in. Okay, I've got that. End and end. Now this plot here, I don't need to look for just those points that are in anymore because all of them are going to be in. We're going to do red stars with them. We don't need to do the blue dots if it's out because none of them will be out. And let's run this. F5 to save and run. And there's my 1 point. Now the problem is I wanted to store all of these points. So I'm going to come in here and make a small change. I'm going to say store x sub I here. So I'm storing that each time through the loop, I is going to be 1, then 0, or 1, then 2, then 3, and so on. So now each time through the loop, I'll be looking at just the one vertice that is current. But then when I plot it, I'll do all 20 or 30 or however many there are. Let me save and run this. And there we are. We have solved this problem. Sometimes you get goofy polygons like this that are sometimes in and sometimes out because it's crossing across itself. But if I run again, I'll find a much better behaved polygon. Okay, and I guess I could just make this a little bit easier by setting the value down to 3 so it's a triangle. And that's much saner looking. As the final test, I want to display the values of those points. So I'm going to say display x as a column vector, y as a column vector. Like to put brackets around those so it's one big matrix. Now let's hit F5 to save and run. And there we go. Alright, I hope this helped to see how I solved a problem like this from beginning to end. Thank you.